Okay, the next question is from JEE 2004. Here, an initial molecule is given, which is there is a benzene ring and CH2Cl is attached to it. Then we have KCN and DMF. Now it's very evident from the solvent itself. We have already discussed that DMF is a solvent. We don't have to be confused what it will do in the reaction. It will not participate in the reaction. It's only a solvent. Also, it is a aprotic reaction. It's a aprotic solvent. So these two things should be known about this DMF, that it will act as a solvent, it will not participate in the reaction, and it's a aprotic reaction, aprotic solvent. So we have to understand what will happen now. Now this KCN can be understood as K plus and Cn minus. Cn minus is a very strong leaving group, strong nucleophile. Okay, and this Cl is a leaving group. So it's a very straightforward reaction. This Cn minus will come and attack here. There will be a backside attack, and this Cl will leave. Hence, it will be a SN2 reaction with the product being CH2Cn. Now, it cannot be an elimination reaction because you have this carbon which is the part of benzene ring. So this H cannot be eliminated. So it will only be a substitution nucleophile reaction and not a elimination reaction. Okay, so the next question is from JEE 2001. The question is, an SN2 reaction at an asymmetric carbon of a compound always gives. Note the important keywords. We are talking about a SN2 reaction at a asymmetric carbon. Asymmetric carbon of a compound always gives, and then we have 4 carbons. So first we have to understand both these terms. What is a SN2 reaction? We already know SN2 reaction, and asymmetric carbon means a carbon which has all 4 valencies different, that is A, B, C, D. It has all 4 valencies different, that is it will be a chiral carbon. Okay, so we'll look what options are given. The first one is an enantiomer of substrate. Okay, let us assume this asymmetric carbon as we have one leaving group here and 3 more valencies, let's say A, B, C, and enantiomer of substrate. The B option is a product with opposite optical rotation, a product with opposite optical rotation. The C option is a mixture of distereomers and the D option is a single stereoisomer. Now, in SN2 reaction, it is known that it is a stereo specific reaction. So, SN2 reaction is stereo specific reaction. And what this stereo specific means? It means if we have a single reactant, then the product will be unique. A unique reactant will give a unique product. So we can at once say that this D is correct. But let us understand what A, B, C are saying. These are saying an enantiomer of the substrate will form. This is completely wrong, because if we see, the initial reactant has this leaving group, while the final product will have nucleophile. So these initial and final products will not be related at all. Leave alone this enantiomer thing. These two will not be related at all. A product with opposite optical rotation. Once we have changed all four or any of the substitute of a carbon atom, of a chiral carbon atom, we cannot comment about what its optical rotation will be after the reaction. We don't know whether it will be opposite or the same. We cannot comment on that until and unless we know all the four groups. A mixture of diastereomers, no, it cannot be a mixture, because SN2 reaction is a stereo specific reaction. It will yield a single specific product. A unique reactant will give a unique product.